Hi class, and finally we're back to doing class again. Hope things went okay for you on the quiz, and we'll have 2 more sections in this chapter and we'll be finished with it. Then we have 1 more section in chapter 9, so we're cruising. We're doing pretty well. Anyway, we have a little bit more factor to do, but before we do the factoring, I want to go back to one of our earlier sections where we were multiplying numbers that look like this. So let's take a look at number 1, x plus 7 squared. And so to do this one, we're gonna multiply. Let me okay. All right, we're gonna multiply the x plus 7 times the x plus 7 because this is x plus 7 squared. And we will go ahead and do our FOIL. We're going to multiply the first terms. We get x squared. And outside terms, plus 7x. Inside, 7x. And then outside again, 49. So together we get x squared plus 14x plus 49. And you may already remember that there was an interesting pattern to this product of a binomial square. If you look at the original problem, you have x plus 7 squared. And you might wonder, well, how is this original problem related to what we're looking at? Well, if you look at the 7, and you square it, that's how you get the 49. How do we get the 14x? Well, if you multiply these two numbers together and then double them, you will get the 14x. And that was a little pattern that we learned back in the day. So I want to make sure that we are able to recall that, and we can do these again. What I'd like to do is I'd like to be able to get to the pattern as soon as we can. But let's go ahead and multiply them out again using FOIL. But after we've used FOIL for a while, I want you to recognize that we can shortcut this. So anyway, let's go to one other thing though. I forgot to say that this x squared comes from this first number squared, right? Anyway, let's go to this number, 7x minus 3 times 7x minus 3. All right, 7x times 7x is 49x squared. I should probably change the color of this pen for now just so I can distinguish from what's going on next to it. And then I multiply the outsides, I get minus 21x. I do the insides, I get another minus 21x. And then the outsides gives me the positive 9. So all told, I get 49 x squared minus 42x plus 9. Again, if we look at the original problem, 7x minus 3, we could have gotten this using a shortcut method of squaring the first term to get the 49x squared, second term to get the 9, and then we multiply these two together and we double it, multiply by 2. So negative 21x times 2 gives us the negative 42x. Okay, so what I'd like to do is just go right to the pattern and see if we can't use the pattern to understand how we get this number. Now what we're going to be doing in a moment is we're going to be undoing this process. So what I want to do is remind us how we multiply these out so that we can undo it in what they call factoring. So okay, let's use the pattern. So the first term, if I'm gonna square a binomial, the first term squared will be 16x squared. How do I get the middle term? Well, I get the middle term by multiplying the first term and the second term, and then doubling that. So 4x minus y times minus y is negative 4xy. I double it for negative 8xy. I wish they didn't get those double letters going on there. Probably blowing your brains out already. But anyway, that's what it is. Again, if you multiply positive 4x times negative y, you get negative 4xy, which we need to multiply by 2, and that gives us the middle term. Okay, now the last term is minus y times minus y for just y squared. Let me make a little bit more space there. So that's going to be plus y squared. All right, so that's the pattern. Again, let's do one more like that, okay? So again, first term, square the 3m, and you get 9m squared. The middle term, we get from multiplying these two together and doubling it. So 3mn times 2 is 6mn. And then the last term is this one squared, right? And that's going to be plus n squared. Okay, those were really not the easiest ones to multiply, but hopefully you got the pattern, right? Square the first term to get the 9m squared, multiply the two terms and double them to get the middle term, and then square the last term to get the last term. All right. So we're going to use that. We're going to use that in a little bit. Just see if you can, hold on to that for a moment. So those are called binomial squares. The other thing that we learned a few chapters back and even before the break was the product of these two. Now these look like they're the same, but they're not quite the same. You'll notice that one has a plus in the middle and one has a minus in the middle, and that's what makes them different from the ones that we just did. So let's see what happens when we FOIL these. So ready? So let's go ahead and you're going to see that a similar thing happens each time we do this, and hopefully you'll remember it. So first terms is going to be x squared, and then outside terms minus 10x, inside terms plus 10x. Stop making a mess here. Plus 10x. And then the last term is going to give us negative 100. So you'll notice that these cancel out. I get x squared minus 100. Hopefully this is looking familiar to you. Let's look at this next one. 2x times 2x gives me 4x squared. Let's do the outsides, and we get minus 2x. Insides, plus 2x. And then the last terms, minus 1. Again, canceling for x squared minus 1. All right, so remember how we got that. These were called differences of two squares. At this point, you guys might already figure out that these are what I called conjugates, and to multiply them, if we recognize that they look the exact same except the sign in the middle is different, all we have to do, we don't have to FOIL because we know the O and the I will always cancel. We just have to FL. So this one just becomes x squared minus 9y squared. So I just multiply the firsts and the lasts for these kinds of terms. So this again is just a review of some stuff that we did once before, and will be information that we'll be using in a moment to factor some other problems. So anyway, this is class notes, right? And what I'll do, guys, is I will make a copy of these notes once they're finished, and I'll post them on my essay. Okay, so let's go to what's going on. So if you remember what we were just doing, we were producing these types of numbers just now. X squared minus 25. So what did the x squared minus 25 come from? Well, it came from a difference of two squares. So if you can remember, x squared minus 25, going in reverse, we take the square root of the first term, which is x, and we take the square root of the second term, and we put it here. we make one plus, and we make one minus. And that's the factorization of that. If you multiply those out, you get x squared minus 25, right? Do FL, right? F, firsts and last. X squared minus 25. Yes, yes. So, again, let's go ahead and do this one. You got 4z squared minus 1. So, we're going to make our two parentheses. And in the first place, we're going to do the square root of 4z squared. Now think about it. What number multiplied by itself gives me 4z squared? It's 2z. See if you can convince yourself that I didn't cheat you there. Now we do the square root of the second term. 1 and 1. And we put a plus in the middle of one and a minus in the middle of the other. Doesn't matter what order. Okay, so now I'm going to challenge you guys to do these questions here. If you have already printed out this note sheet, this note packet, then you can just do it underneath there. But otherwise, let's go ahead and I'm gonna do the last one for you, and you guys can do. No, I'm gonna do. I'll do number 3. I'll do number 3 for you, and you guys can do 1, 2, and 4. All right, but let me do 3 first. All right, set up my parentheses. This is a difference of 2 squares, all right? Because this is a perfect square, and this is a perfect square. That's a perfect square because its square root is 3n, which I'll put at the front of both. And and 16 is a perfect square, which means that there's a number that I multiply by itself, which is 4. And I go minus sign, plus sign. Done. Okay, let's go ahead and you guys, I'm going to pause and you do, and we'll do number 1. Okay, if you pulled that one off, you got x minus 6 times x plus 6. Again, the key to these is recognizing that the first term is a perfect square, and the second term is a perfect square, and that there's a minus sign in the middle. There's a question on the homework that's going to test to make sure you recognize that there has to be a minus sign in the middle for this to work. If it's a plus sign, you can't factor it. Okay, let's pause and do number 2. Okay, on this one, the square root of 100 is 10 and 10. Square root of m squared is m and m, and I put a plus in the middle of one and a minus in the middle of the other. Okay, that brings us to number 4. Give that one a shot. Okay, a little trickier here. 16h squared. What times itself is 16h squared? Well, that's 4h. And so put the 4h in the beginning, in the front, and then I have square root of 49 is 7 and 7. So there we go. Okay, so now we're going to move on to the next one. Now, if you remember from the beginning, we had another type of problem that we were doing, and that was a polynomial square. Now, what I'm going to do is I'm going to factor the first one, just doing it regular. But what you want to recognize though is if I take the square root of this number here, 4, and then I double it, I get the 8. This is, or actually the other way we were doing it, I think the way we were doing it in class was we're saying if we take the 8 and have the 8, you get 4, and then square it, you get the 16. Basically what I'm trying to say is that all these problems here are binomial squares. So all the ones that you're going to factor tonight are going to factor pretty easy. You're going to have the same factoring pattern, and you'll get used to it. But if you want to, we can just go ahead and do it the old-fashioned way. And doing it the old-fashioned way, we put an n here and an n here, and we look for two numbers that multiply to 16 and add up to 8, which in this case is going to be 4 and 4. Okay, again, these are going to be trinomial squares, so in other words, it's going to be the same number twice, which makes it a lot easier to factor. So in this case, if it's going to be the same number twice, we're going to divide this, we're going to make this 2x and then make this 2x. And it is likely that we're going to look for, we need a number we need two numbers that multiply to 9 that are the same number. Well, what times itself is 9? Well, it's going to be 3. And I'm going to put a minus sign in between here because, and you can see if you can tell me why. Think about it. Why did I put the minus sign? Well, it's because the outside and the inside terms, if you look at the OI check, it's going to be a negative 12. So we need to make sure that those numbers are negative. All right, so let's go ahead and factor a couple more here. What I'm going to do is I'm going to ask you to pause and see if you can't factor the first one. Okay, on this one, we should have gotten m minus 1 squared. Okay, number 10. Pause and do this one. On this one, I just recognized that this was a trinomial, a perfect square trinomial. The reason being is anytime if I take this number, take half of it, and then I square it, and I get that number, that means it's going to be a binomial square. To do the last one, you will need to recognize that, and there's a couple questions like this in the homework. What you need to recognize is if we're ever going to fully factor anything, we always have to get the greatest common factor out first. And I don't know if you noticed, but do you see that every one of these numbers is divisible by 9? And so that means that before we start factoring, we should take that 9 out. So let me rewrite it down here just to make things clear. And I will take a 9 out and divide everything on the inside by 9 to do that. So I'm going to get 9 times z squared plus 4z plus 4. And again, this is a trinomial square, and you can factor it. So this becomes 9. Why is this a trinomial square? Because I said half the middle term is 2, and square it. If half the middle coefficient squared is the last term, you got it. It's a trinomial perfect square, which means we just need to get the square root of the first term and the square root of the second term, the f and the l of FOIL, and the sign of the middle term, so it's going to be plus. And then we put a squared out here. So that is this one. That's a little tricky, but I do have a couple on the homework that are going to be like that. So watch out for those in the later part of the assignment. Okay, so one other thing that we may see on the assignment is the following, is if we get something like, say I had a question like x squared minus 16 equals 0. So this one is actually a solve, and because it's a quadratic, we need to solve it by factoring. So in situations like this, we need to factor it first. In this case, we're going to get x plus 4 times x minus 4 equals 0. And this is when we can say that, well, that means that either x plus 4 equals 0 or x minus 4 equals 0. Add minus 4 on here, you get x equals negative 4. Add 4 over here, and you get x equals positive 4. So you get positive and negative 4 as the answers. So be looking for questions that like that where you're solving by factoring. You could also get a trinomial perfect square, a perfect square trinomial to solve, or something like that also. But anyway, hopefully you get that some of that made sense. If you do you can go ahead and get started on the homework, but if you remember, we can always do the homework during our Meet sessions, our Google Meet sessions. It might be worth going ahead, though, and taking a look at the homework assignment just to make sure you have some sense of what's going on. Otherwise, guys, have a great day, and I'll see you soon. Bye.